The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on to chapter 14, section 1. But before we do that, do you have any questions from last night's homework 4.5 that you'd like me to look at before we proceed? Any questions? All righty, I'll take that as a no. So today, section 14.1, the topic of the day is factorials. Okay, so we're going to talk about factorials, what they are, how to simplify them, etc., etc. All right, so first of all, let me just introduce, well, let's just start with this. Okay, this would be 5 factorial. So when a number is followed by an exclamation mark, that exclamation mark implies that we're taking 5 factorial. Now, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Let's see. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. So 5 factorial equals 120. Let's look at another example. How about 3 factorial? Well, 3 factorial is equal to 3 times 2 times 1. 3 times 2 is 6, times 1 is 6. So 3 factorial equals 6. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But that would also be equal to 7 times 6 factorial, right? Because 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. 7 factorial also would be equal to 7 times 6 times 5 factorial, because 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So do you see how we could write it in different ways depending on what we wanted to do with that? Also, by definition, 0 factorial is equal to just the number 1. So let's see how this can work, how we can simplify things without it getting too difficult. Let's see. Let's say we've got 3 factorial times 4 factorial. Well, 3 factorial would be 3 times 2 times 1. And 4 factorial would be 4 times 3 times 2 times 1. So if we multiply this all together, 3 times 2 is 6, times 1 is 6, times 4 is 24, times 3, let's see, 24 times 3 is 72, times 2 would be 144, times 1 would still be 144. Okay? Now, we could do this on our calculator, I suppose, you know, 3 times 2 times 1 times 4 times, etc., etc. There's also a way to just enter factorial on the calculator, and I'm going to talk about that, but not quite yet. We'll get to that later. Let's say I have this expression. I have 49 factorial divided by 47 factorial. Well, the long way of doing this would be to say 49 factorial is 49 times 48 times 47 times 46 times 45, etc., all the way down, which would be horrible. And then in the denominator, 47 factorial is 47 times 46 times 45 times 44, etc. But we could do this instead. We could take 49 factorial and write it as 49 times 48 times 47 factorial. Recall 47 factorial would give you all the rest of the factors, and then leave 47 factorial in the denominator. And then we could say, well, what's 47 factorial over 47 factorial? That reduced to 1 over 1. So now my problem is just 49 times 48. And I'm going to go to my handy dandy calculator and go 49 times 48, and that is 2,352. But my point is, I only had to multiply 49 times 48 because everything else reduced out. Any questions about how I did that particular example? All right, let's take a look at another one. Let's see here. How about 9 factorial over 7 factorial times 0 factorial? Well, because I have a 7 factorial in the denominator, I'm going to take 9 factorial and write it as 9 times 8 times 7 factorial. In the denominator, 7 factorial times, remember, 0 factorial is just 1, okay? So now I could reduce the 7 factorials down to 1 over 1. So in the numerator, 9 times 8 times 1 is 72. In the denominator, 1 times 1 is 1. So my final answer is just 72. So again, all I really needed to do was take 9 times 8 because everything else reduced down to 1.
Could you explain how you got the 8 again? Sorry.
Where I got the 8?
Yes.
Okay. So 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that's just definition 9 factorial. Are you all right with that?
Yeah, got it. Thank you.
Yeah, sure. All of that could be written as 7 factorial. So that's where I got 9 times 8 times 7 factorial. Does that make sense?
Yep.
Okay, great, great. Anybody else confused there about anything?
Yeah, so would that go for any number that's factorial?
When you say would that go for, what do you mean by would that go for?
How you extended it from 9
Yes.
to 1?
Absolutely.
Only if it's factorial though?
Correct, correct.
Okay.
This symbol, factorial, means that you're going to have those factors from the original number times each decreasing all the way down to 1. Yeah. Okay.
What would the difference be between 0 factorial and 1 factorial?
Nothing.
Okay, that's what I thought. Thanks.
Yeah, it's just kind of one of those things that it works by defining it that way. So yes, you are correct. Now, you couldn't do this. If you said 3 factorial was 3 times 2 times 1, oops, times 0, now all of a sudden you've got 0, right? So you've got to stop at 1. But 0 factorial is just the number 1.
Thank you.
Okay. How about this? We've got 15 factorial over 14 factorial times the quantity 15 minus 14 factorial. All right. So in the numerator, I've still got 15 factorial. In the denominator, 14 factorial. What is 15 minus 14?
1.
So this would be times 1 factorial, right? Okay. Now, because I've got this in the denominator, I'm going to take my numerator and write it as 15 times 14 factorial. So then I can take the 14 factorial in the denominator and reduce it or simplify it out. See how I did that?
So every time you have a repeating number on the denominator as the numerator, you just cancel it out.
Yeah, you could reduce it out, get rid of, yeah, you get rid of it. So now what do I got? I got 15 over, what's 1 factorial? That's just 1. And 15 over 1 is 15. Any questions about that problem?
Nope.
If I'm ever going too fast and I go on to the next problem and you're not done writing, let me know. I can always go back. I'm not in any hurry. I'm not going anywhere. All right. How about this one? 6 factorial divided by 4 factorial times the quantity 6 minus 4 factorial. So again, in the numerator, I've got 6 factorial and the denominator 4 factorial. What is 6 minus 4?
2.
So this would be 2 factorial, okay? Now, since I've got a 4 factorial in the denominator, I'm going to take the numerator and write it as 6 times 5 times 4 factorial, okay? So that I can knock out that 4 factorial in the numerator and the denominator. 6 times 5 is 30. 2 factorial would be what? 2 times 1. So 30 over 2, which is 15. Okay. Any questions about that? Okay, let's take a look at another example. Are we good to go on? Yeah, all right. 5 factorial times the quantity 8 minus 5 factorial over 4 factorial times 7 factorial. This whole idea of factorials, Math 93 is a prerequisite for several different classes, one of which is statistics. And I believe that in statistics, you'll be using factorials. So again, this may not seem that related to the previous sections we've looked at, but it just kind of depends on which class you're going to take after this. All right, now, first of all, I'm going to do what's in the parentheses. 8 minus 5 is 3, so this is going to be 3 factorial. So now I've got this situation, okay? Now, there are several different ways I could reduce this down, but I want to do it in order to basically get rid of the most numbers that I can. So what I'm getting at is that I could take these two and deal with them. I could take these two and deal with them. I could take these two and deal with them. I could take those two and deal with them. There's a variety of different ways that I could do this. So what I'm going to do, I'm going to recopy that down here. I want to get rid of the most I can by reducing things. So what I'm going to do, I'm going to put these two together, and I'm going to put those two together. And what I mean by that is this. Okay. I'm going to leave 5 factorial there. And I'm going to leave 3 factorial there. I'm going to take 4 factorial and write it as 4 times 3 factorial. I'm going to take 7 factorial and write it as 7 times 6 times 5 factorial. I guess I should just use x's for all my multiplication. Why do that? Because that allows me to knock those out, turning it into 1 over 1, and to knock those out, turning that into 1 over 1. So now my numerator is 1, and my denominator is 4 times 7 times 6. And let's see. 4 times 7 is 28 times 6 is 168. So I get 1 divided by 168 as my final answer. So again, do you see how I'm trying to get rid of the most that I can? Now, I could also have dealt with those and dealt with those. See what, let's look at that. Let's do it that way and see what the result is. So 5 factorial, we'll go times 3 factorial over 4 factorial times 7 factorial. Let's say that instead of doing what I did here and putting these together and those together, let's just do oops, come back here. Let's put these together and those together. All right. So I'm going to take 5 factorial and write it as 5 times 4 factorial, and then leave 4 factorial in the denominator. And then I'm going to write 3 factorial on top, and I'm going to write 7 factorial as 7 times 6 times 5 times 4 times 3 factorial. Why do it that way? I can get rid of the 4 factorials and the 3 factorials, okay? So now I've got more numbers there, but even so, it's still not too bad, because what could I do next? Is there any other reducing I could do before I multiply stuff out?
Take away the 5.
Exactly. And at this point, I've actually got the same scenario that I had before. I think it was what, 168?
Yes.
Yeah. So even that wasn't too bad. But again, there's a variety of ways you can reduce this down, but anything you can reduce out first will save you having to multiply stuff out by hand or by your calculator. All right with that? Let's see. Here's one more coming up. 6 factorial times 7 factorial. In this context, all my x's are multiplication symbols. They're not variables. Okay. And then I've got 8 minus 3 factorial times 7 minus 4 factorial. So again, the first thing I'm going to do is clear my parentheses, simplify those out, I mean. So in the numerator, I've got 6 factorial times 7 factorial. 8 minus 3 is 5, so 5 factorial times 7 minus 4 is 3 factorial. Okay, so again, I want to wipe out as much as I can. I'm going to put these together and those together in terms of reducing things out. So I'm going to take 6 factorial and write it as 6 times 5 factorial. I'm going to take 7 factorial and write it as 7 times 6 times 5 times 4 times 3 factorial. I don't know, can you still see that over there? Can you see the 3 factorial, or is it off the screen?
Yeah, we could see it.
Okay, okay. So now this allows me to reduce out the 5 factorials and the 3 factorials. So I've got 6 times 7 times 6 times 5 times 4 over 1 times 1. And so now on my calculator, I'm going to go 6 times 7, which is 42, times 6, which is 252, times 5, which is 1260, times 4, and I get 5,040 over 1, or just 5,040. Okay. Any questions on that? Well, now let's go back and let's deal with factorials using the calculator. For instance, what if I wanted to find 11 factorial? I wouldn't want to sit there and go 11 times 10 times 9 times 8 times 7 times 6. I could do that, but it would be nicer if we could use a calculator. All right, now, the calculator button that gives you factorials is a button that's going to have an exclamation mark. On the TI 30, let's see, what is it? I think it's Roman numeral 2, or TI 30X, Roman numeral 2 or whatever. I believe there's a button. Sorry? Oh,
It's
okay.
the
There's a-
TI-30X West.
Okay. I believe there's a button that says stats. See if you can find that button or just stat. I think it's towards the top, kind of in the middle. You find it?
Yep.
Okay. Push the second key up in the upper left and then push the stat button. Does it give you some options, one of which is that symbol?
The online one does.
Okay, well, I was going to go to online, but I believe that on the regular calculator there, on your scientific calculator, does that button show up when you go second and then stat? Yes or no?
No, I got a stat error.
Okay, hang on then. Let's see here. Unfortunately, all my TI 30X whatever calculators are in my classroom and I couldn't get in there. So let's see here. TI 30.
Oh, I got it. It's the button that said data and it says stat on top of it.
Ah, okay, okay. Let's see if I can get. Ah, yes, thank you. Okay, so here's what I'm going to do. I was remembering it incorrectly. Can you see the calculator now over here on the left? Or
Yes.
Yes.
so I got to be careful what I do. Right here, well, over on the screen where it's larger, you can see where it says data or data. So second and stat. When you push that button, then do you get several choices, one of which is the exclamation mark key?
Yes.
Okay, all right. Now, so you could use that button. The other option is you could do this. You could go into just any of your web browsers and type scientific calculator. And if this one shows up, this is a great one to use. I don't know, last quarter, for whatever reason, when I typed in scientific calculator, this wouldn't show up, but now this quarter it is. So I don't know if you can't get this one to come up on your screen, instead of typing in scientific calculator, type in Factorial Calculator, and that will give you some options. But on this calculator, this button right here is the Factorial button, okay? So let's say, I think my original problem was 11 factorial. Okay, see how I did that? What does that equal? Let's see, that would be 39,916,800. Okay. Any questions on that one? Let's do 41 factorial. Okay, now what's going on here? So what this represents, this little E is just the calculator's way of saying that it's going to be in scientific notation. So this is 3.3452527 times 10 to the 49th power. Okay, let's take a look at that again here for a minute. So 3.34527E plus 49. I'm going to go back to my whiteboard screen here. So that's what we're seeing up there that I just got rid of. This is 3.3452527 times 10 to the 49th power. But it doesn't show up that way on the calculator screen. Some calculators do have it, but often it has this little E thing, okay? So that means times 10 to that power. Any questions about that? So all of these problems, except these last few where I had a large number factorial, you could do by just simplifying things and then multiplying out what's left. You could also use your calculator and your factorial button, but I actually think it might take you longer to do that than to just do it out by hand. But I'd like you to practice doing it out by hand. But you get something like this, something really big, like, you know, let's see, 17 factorial, rather than doing it by hand, punch it into a calculator. Okay, let's do that one. 17 factorial. Okay, clear 17 factorial. So there's that times 10 to the 14th power as well, 3.5568743 times 10 to the 14th power. Does anybody have any questions in terms of using either your calculator you've got or the online calculator here to calculate a factorial? Do you have any questions about that? Okay. Well, that's all we're going to look at today. It's a shorter lesson. Hopefully that'll give you a chance to get caught up if you don't have yesterday's lesson done. Just a word of advice, unsolicited advice. So each assignment, you technically have that this day and then all of the next day up until 11:59. Don't wait until the second day at 10 p.m. to start your assignment. The idea is that you do your assignment on the first day that it's assigned, so that if you have questions, you can ask me the next day in class if you need to, and still have time to wrap it up. But some of these assignments are short, some of them are long. We're going to even have days where there's actually going to be 2 assignments in the same day. But again, you've got 2 days to finish them, which should be plenty of time. All right, having said all of that, I'm going to go ahead and stop the recording.